Developing an environmental management system can help with the compliance and operational systems involved in the cannabis business. Environmental management systems can be as simple as routine inspections and documenting the operational processes, or as detailed as developing standard operating procedures, inspections, and routine analytical testing to ensure there is no PFAS chemicals in the plants and in the final cannabis product.
Welcome to A Higher Law, a cannabis podcast from the Dykema law firm. I'm your host, Grant Gilezan, and I head Dykema's Environmental Practice Group. For more episodes, you can find us at dykemapodcast.com, youtube.com/Dykema Law, or by searching A Higher Law wherever you get your podcasts. Today's episode will cover the developing requirements and risks for the cannabis industry associated with PFAS, the so-called forever chemicals. Joining me is Bill Henderson, who is Vice President of Darcy Environmental Consultants. Bill and I have been working together on environmental projects for over 30 years. It is said that PFAS is ubiquitous in the environment, such that the only places we are not finding it are the places we are not looking. Before getting into how these particular chemicals have implications for the cannabis industry, it would be helpful, Bill, if you could explain what is meant by PFAS and how it has been used over many decades, particularly for consumer goods.
Yes, Grant. Thanks. Glad to be here with everyone. PFAS are classified as forever chemicals, meaning that they last a long time in the environment, meaning lifetimes or decades, if you want to call it that. PFAS is an acronym for polyfluoroalkyl substances, and there are thousands of PFAS chemicals, and they are found in many different consumer, commercial, and industrial products. An example is nonstick cookware, stain-resistant fabrics, food packaging, cosmetics, and probably the most that everybody's heard about is firefighting foams. The reason they last so long in the environment is that PFAS are synthetic chemicals that repel water and oil and resist degradation. Therefore, PFAS are widely used, long-lasting chemicals, components of which break down very slowly over time.
Despite many decades of use, it has come to light that PFAS has only recently reached an active level of public awareness and concern, placing it quickly in the same ranks as asbestos, lead, and mercury because it is both pervasive and persistent over a long period of time in the environment. The US EPA has a growing list of health effects associated with PFAS, including increased cancer risks, reproductive effects, developmental effects or delays in children, reduced ability of the body's immune system, interference with the body's natural hormones, and increased cholesterol levels and a risk of obesity. Bill, could you please overview how PFAS has become so prevalent in the environment and, unfortunately, in all of us?
Grant, with thousands of PFAS chemicals, this makes it challenging to study or assess the potential human health and environmental risks. As we learn more about PFAS in the environment, we can understand the exposure and risks from these chemicals. PFAS can get in the environment in many different ways. As an example, water washed over a consumer product with PFAS can enter drain systems such as your sink, or through firefighting foam washed into a bare ground surface or washed into a sewer system and get into the surface water through discharges or into the ground through septic systems. Once the PFAS chemical contacts the soil, it binds to the soil particulates or leaches through the soil to get into the groundwater. Once in the groundwater, PFAS will disperse and migrate with the flow of groundwater direction and spread out, possibly over long distances. PFAS has been identified in many sites in Michigan around military bases, manufacturing, or industries. PFAS has been identified in residential drinking water wells near these military or industrial sites. PFAS has also been found in community wastewater treatment plants, so there's evidence that PFAS is present in sanitary sewer systems that collect wastewater from residences and commercial businesses. In my experience, I find PFAS chemicals in groundwater on properties at or near industrial sites. Since PFAS is everywhere, we need to take extra precautions when we collect samples and have them analyzed in a laboratory. There is an extremely rigorous procedure to sample the soil or water for PFAS to avoid cross contaminating a sample so we can get an accurate result of what concentration is truly in the environment. The common exposure to PFAS is through ingestion by eating food contaminated with PFAS or drinking water contaminated with PFAS. Dermal contact is also a potential exposure route with commercial industrial products in the workplace or from PFAS treated products like carpet or upholstery stain protection materials.
These human exposure concerns that Bill just outlined for us, and there are many, are now driving the rapid creation of human protection standards. On the federal level, U.S. EPA developed in 2021 a PFAS strategic roadmap, which laid out a planned approach to addressing the toxic and persistent chemicals and safeguarding communities from their reach. In implementing that roadmap, U.S. EPA has proposed drinking water standards for PFAS, which are anticipated to be in place by the end of this year. It is also preparing to add early next year some PFAS to the list of substances with cleanup criteria when found in soil, groundwater, and surface water. Interestingly, the states are starting to jump ahead of US EPA in that several already have enforceable drinking water and soil cleanup standards. Bill, could you please describe which PFAS are being prioritized among the thousands of chemicals regarded as within the PFAS family for regulation, and then give some examples of the low levels being set compared to sampling detection limits?
As we mentioned earlier, PFAS is made up of thousands of chemicals. The chemicals that are commonly regulated today include PFOA, which is PFOA, and PFOS, which is PFOS, which are the two most common. Also, there is PFNA, PFHS, PFHA, PFBS, and HFPODA. These PFAS chemicals are regulated by US EPA. PFAS are also being studied and monitored by other agencies such as the CDC and state governments, like the Michigan Department of Environment, Great Lakes, and Energy. The Michigan EGLE is one of the states that has been at the forefront of the PFAS studies. On August 3rd, 2020, the groundwater cleanup criteria for drinking water for PFOA became 8 parts per trillion, and for PFOS became 16 parts per trillion. Then on December 21st, 2020, 5 additional PFAS compounds became effective and enforceable groundwater cleanup criteria for drinking water. PFNA at 6 parts per trillion, PFHS at 51 parts per trillion, PFHA at 400,000 parts per trillion, PFBS at 420 parts per trillion, and HFPODA at 370 parts per trillion. These criteria are extremely low and are referenced in parts per trillion. Most other chemicals regulated by US EPA and the individual states are referenced in parts per billion or parts per million. So PFAS chemicals are measures of at least 1,000 times less. There are also PFOA and PFOS established criteria in parts per trillion for surface waters that are used specifically as drinking water sources. As of June 2023, US EPA and several states have developed additional residential soil criteria in parts per trillion for a few of the PFAS chemicals, primarily the PFOA and the PFOS.
As a result of these health concerns, the regulatory focus on PFAS is beginning to expand, now sweeping in packaging materials, textiles, personal care products, cookware, water, and other consumer goods, including cannabis products. Bill, could you please explain the aspects of cannabis raw material, processing, and finished products which could involve PFAS?
Okay, plants are made up mostly of water. So plants that take in more water and nutrients means that plants tend to take in larger amounts of contaminants as well. Plants also take up contaminants such as PFAS through their root systems in the soil. Specifically, PFAS contamination can enter hemp or cannabis products through various pathways such as irrigation water, nutrient delivery systems, and soil. Getting into the detailed science, plant uptake can vary due to a number of factors such as soil carbon, organic matter, mineral content, structure, and polarity of the PFAS molecule, plant protein, and lipid content, as well as pH. There are short chain and long chain molecular PFAS chemicals. The long chain PFAS, which is more like the PFO and the PFOS, are known for bioaccumulating in animals and in the environment. Short chain PFAS are generally more water soluble, and since our environment and plants consist mostly of water, short chain PFAS mingle and move about more readily. It has been found in research that short chain PFAS move freely in above ground plant parts, partly because they don't sorb or bind readily in the soils. Short chain PFAS have also been found to accumulate around the root zone of potted plants, since the container can trap the PFAS inside. Therefore, if PFAS chemicals are in the potted soil or water used to irrigate the plants, PFAS will absorb into the cannabis plant. When someone then ingests the cannabis, they will also ingest the PFAS in the cannabis plant.
As a result, many of states now recognizing this are developing complex regulations for PFAS in food or other types of packaging that also could apply to medical or adult use cannabis businesses. Some states have already started to phase out PFAS in food packaging and have otherwise started restricting the sale of certain products containing PFAS, such as firefighting foam, cosmetics, rugs, and furniture. Minnesota offers us a preview of PFAS requirements specifically impacting the cannabis industry. In May of this year, Minnesota became the first state to regulate PFAS in cannabis packaging. That law states that packaging for cannabis flower, cannabis products, lower potency hemp edibles, and hemp derived consumer products must not contain or be coated with any PFAS. And edible cannabis products and lower potency hemp edibles must not be packaged in a material that is not approved by the United States Food and Drug Administration for use in packaging food. Bill, it seems very clear that PFAS regulation is coming soon to the cannabis industry indeed. But understanding it and preparing for it operationally will be challenging because of the dynamic state of regulatory activity and because the industry involves a multi state supply chain of materials and product distribution network. How would you suggest, Bill, cannabis companies prudently plan for their operations and products to be in place to meet these new requirements as they come online?
Yes, developing an environmental management system can help with the compliance and operational systems involved in the cannabis business. Environmental management systems can be as simple as routine inspections and documenting the operational processes, or as detailed as developing standard operating procedures, inspections, and routine analytical testing to ensure there is no PFAS chemicals in the plants and in the final cannabis product. Easy places to focus an environmental management system would include: where does the source of the soil come from that is used for the plants, and was it tested to be free of PFAS? Is the water used for irrigation of the plants free of PFAS? Are the potting containers free of PFAS? And is the packaging material of the retail product free of PFAS. Each of these listed items can have a written procedure and or quality control procedure to document that the final product is free of contaminants like PFAS.
It is very important that one recognize that US EPA's PFAS roadmap not only sets out compliance objectives, but enforcement measures to ensure that compliance. US EPA has said it will hold PFAS manufacturers, industrial and commercial users of PFAS containing materials, and distributors of PFAS containing products responsible for the substance's widespread environmental and human impacts. In addition, we are already seeing states giving increased attention to PFAS in cannabis, cannabis products, and cannabis product packaging, particularly in states that have both legalized medical or adult use cannabis sales and implemented PFAS restrictions related to other products. Based on your experience in other areas of regulation, Bill, how would you expect agencies to ensure cannabis operators are complying with applicable PFAS requirements?
Grant, the regulatory process is changing rapidly as we learn more and more about PFAS chemicals and their effects on people and the environment. In the environmental industry, we are seeing the regulatory agencies paying more attention and investigations tailored to include PFAS sampling and laboratory analysis. With more regulation, businesses can expect increased inspections, government oversight, and unfortunately, violations. It is prudent for businesses to understand and be aware and minimize the potential for PFAS chemicals to get into the cannabis growing operation and packaging of their products. We can expect to see increased government involvement and inspections when you have situations where toxic chemicals can get into the environment and have exposure to people. It is also common to see government violation letters and fines if businesses are not complying with the regulations.
As you've noted, Bill, the importance of complying with environmental requirements is to avoid statutory fines, which can accrue per day of violation, and having then to invest in efforts to address agency violation notices, which often lead to the development of a consent order that includes additional business costs, such as corrective action plans with schedule deadlines, reporting requirements, and stipulated penalties for additional noncompliance under the duration of the consent order. In severe situations, noncompliance can lead to the stoppage of operations and the agency pursuing enforcement actions against the business and even its individual principals. That is why avoiding noncompliance and being ready for the inspector is an important business objective. As Bill mentioned, conducting operational and supply chain self-assessments are a helpful way to meet that objective, and they can be done in a manner which maintains legal privilege and confidentiality over the findings. Plus, any findings of noncompliance may be able to be self-reported and then self-corrected in a manner which significantly reduces or even avoids altogether any risk of being assessed a fine or needing a consent order for such noncompliance. In closing, Bill and I hope our share exchange today has offered you some insights on how the future is now for PFAS regulation of the cannabis industry, and on how you can best plan forward for your business to meet those requirements in an orderly and cost-effective manner. We'd welcome you to reach us with any questions you may have, and we'd be happy to help you address any particular issues in this space you may be facing. That's it for us today. Thank you for listening. As always, you can find us at dykemapodcast.com, youtube.com/dykemalaw, or by searching a higher